simplex method for linear programming problem, and this method is very widely used in several programs. Okay, so here I have already sent what is the simple the have to check our test of optimality and the test of feasibility. Okay, so where the test of optimality means we have to calculate the factors Cj minus Zj values. Okay, and that Cj minus Zj means this is basically the net effect, and this Cj means your incoming unit profit, or you say, and Zj is your outgoing total profit or cost. Okay, so here basically we have to find out the what is the value of the Cj minus Zj for all basic feasible solution. Okay, and if this all or this is depending on our problem, that is if our problem is of maximization case, then we have to check that our all Cj minus Zj is less or equals to 0. And for the max minimization case, the Cj minus Zj is greater or equals to 0. Okay, so now here we quickly solve a problem which is basically depends on this simplex method. And okay, so now the simplest method. So here, if the problem is use this simplex method, and you have to solve the linear programming. And if the linear programming is you have to solve this maximize the objective function, and that objective function is z. And this equals to 3 of x1 plus 5x2 plus 4x3. Okay, and you're subject to the constraints. There are certain constraints. Constraints are either equality constraints or inequality constraints. And suppose there are constraints are 2x1 plus 3x2, which is less or equals to 8. Okay, and this is 2x2 plus 5x3, this is less or equals to suppose 10. And another one is 3x1 plus 2x2 plus 4x3, this is less or equals to 15. Okay, and your decision variables are x1, x2, and x3. These are greater or equals to 0. Okay, so here these decision variable are greater or equals to 0. This means this may be either 0 or any real value function. Okay, so this is a real value. This means this may be a fraction value. Okay, and this linear programming problem is said to be integer one. Integer one when this are there are some restrictions here. This is x1, x2 greater or equals to 0 as well as that are integer. Okay, so in that sense, here we have to solve out this problem and try to find what is your optimum solution of that. Your x1, x2, x3 are feasible. Feasible means this is satisfies all three conditions. This means this x1, x2, x3 belongs to that bounded region. Okay, and that bounded region is we get from these three conditions. Okay, and here for that x1, x2, x3, we have to find out for which combination of x1, x2, x3 your value of this objective function is maximum. Okay, so this is your simple linear programming problem. But here, if there are certain scenario in which there are some x1, x2, x3 that are your decision variables, and here you have to find out what is the value of x1, x2, x3. But suppose if your objective or decision variables is number of chairs, number of machines, number of workers, and if you try to find what is the value of this number of workers, suppose 2.5. Okay, so in that sense, if the worker or machines is equals to 5 by 2, so this is doesn't make a sense, because if our machine is 5 by 2, so this means we couldn't purchase uh, 2.5 machines. Okay, so this means there are either we purchase 2 machines or 3 machines. In that type of problem, you have to purchase in integer one. So the number of workers is also in integer one, and the number of machines is in the integer form. Okay, so that type of problem is also a linear programming problem, but this type of problem is factorized into the integer programming problem. Okay, so here we did only the general linear programming problem, and we have to solve this linear programming problem by using simplex method. Okay, so what are the algorithm for using simplex method? So if there is a problem, we have to first of all we have to write our linear programming problem in the standard form. Okay, so here the what is the standard form? If this is a maximization problem, so we can write our maximization problem to minimization problem. Minimization problem. So we can write this minimization of your z that equals to minus of maximization. Okay, so this is maximize do Z star. Okay, and what is the value of Z star here? So Z star is simply this is the minus of Z. Okay, so this means you can write out your function if your problem is suppose minimization of Z, you can write that Z. Suppose if your problem is minimum of Z equals to something x1 plus x2 here. Okay, so you can convert this minimization problem by using into the maximization problem by using minus of this maximize of that star, and then what is the value of that star is minus of x1 minus of x2. Okay. So now here, so here we have to find out there are the two main concept here. First one is what is your slack variable and what is your surplus variable. Okay, so if there are the inequalities like this, okay, so if you see that this is your something less or equals to something. Okay, so this means this values are either less than or equals to. So here we change this inequality to equality one. Okay, that's why here we add some variable here, and that is your dummy variable, and that is we know that that is your stack variable, and that because in objective function there are only x1, x2, x3, three variables. But here there is no function of any dummy variable. If we introduce here slash variable, suppose s1 here, s2 here, s3 here, because these three are less or equals to type. That's why here we can write this thing. Okay. Suppose any equation. Suppose if suppose 2x2 minus 5x3. Suppose if this is suppose delta equals to suppose 10. Okay. So this equation can be reduced to if you multiply by minus 1. So this becomes minus 2x2 plus 5 of x3, and this is less or equals to minus 10. Okay. So that's why here we can introduce that term here. Okay. So if we introduce here the any stack variable here, so if we any stack here suppose s, okay, that equals to minus 10. Okay. But here the condition is what is the condition of stack variable? The condition is same because here your decision variables are always greater or equals to 0. So your slack variable is also greater or equals to 0. Our surplus variable is also greater or equals to 0. Okay, so in that sense, if your problem is reduced to in this form, then you will introduce that as okay. If for initial basis solution you putting here x2 and x3, these two are 0, so that implies x equals to minus 10, and this x equals to minus 10 is less than 0. So this is doesn't satisfy our stack variable consider because our stack variable is always greater or equals to 0. Okay, so that means here there is some problem here. Okay, so in that sense, you have to right here if your problem is like that and your b is this bi b1 b2 b3 because you know that this equation can be written in the matrix form like ax is less or equals to b here. Okay, so if this is a with the matrix, the quotient matrix, and x be the your variable x1 x2 x3 and b with the here constant. Okay, so if b is greater than 0, if b is this b is greater than 0, in that sense you have to subtracting some here. Okay, if you have subtracting minus something, then that equals to 10 here. Okay, so no problem here. Okay, so in that case, if you subtracting here and that equals to minus 10. Okay, and if you have to find out what is the value here, because this is your surplus variable, so you have to subtract some amount. In that case, if these two are 0, then x equals to minus 10. The same problem. Okay, so you face same problem here. Okay, in that sense, if you adding or subtracting your surplus variable, okay, so this means that this is your not feasible, not feasible. So that's why we introduce some another variable because we here, and that is your artificial variable. So that case, because we this is feasible solution, if our objective is to get our surplus variable is feasible. In that sense, we have to introduce our artificial. Okay. So now, so this portion we will discuss in tomorrow class or in next class. Okay. So now today we'll simply deal with simply the syntax method. What is syntax method? And this portion we will solve this type of problem in next class. Okay. So now, okay. So if we take this problem, and now we're introducing here some flag variable. So if we introducing flag variable, okay, suppose s1 s2 s3. Okay, so, so this implies that your equation is converted into 2 of x1 plus 3 of x2 plus s1, that equals to 8, and 2x2 plus 5x3 plus s2, that equals to 10, and here 3x1 plus 2x2 plus 4x3 plus s3 is equals to 15. Okay, and conditions are your x1, x2, x3, and slack variables s1, s2, and s3 all are greater or equals to 0. Okay, and what is this is your constants. These are your constants. Okay, so what is your objective here? So our objective is maximize our z subject to the conditions are, because in this case there are x1, x2, x3, uh, and s1, s2, s3. Okay, so there are the six variables here. In this case, x1 has cost 3, and x2 has cost 5, and x3 has cost 4. Okay, and then here we introduce some S1, S2, S3 additional variables. So that's why the cost of that is 0. Okay, because there is no contribution in your objective function. Okay, so now we have to find out what is the value of this Cj minus Zj. So first of all, we have to check that our all Bi's are greater or equals to greater than 0. So we can choose initial basic feasible. Okay, so our initial basic feasible solution. So since all this bi that is greater than 0, so you can choose you can choose initial basic feasible solution. Okay, so how can we choose? This x1 is equals to 0 on putting this x2 is 0 and x3 is 0. So our initial choice is if we're putting x1, x2, x3 is 0, in that sense we get s1, s2, s3. Okay. So here your s1 is 8, s2 is 10, and s3, that variable is 15. Okay, and what is your the objective value is, if we initially we take this x1, x2, x3 is 0. So in that sense this is 0, this is 0, that maximum value is that. Okay. So now we have to find out what is the value of your objective function in each step, and we take that our x1 is is for optimality. Okay, so now we solve this problem by using some initial table, and here we directly show how to write your initial table and how to get your physical solution. Okay, so now the next page. So our initial table is the initial solution. So we have to draw table like that. Okay. Here this is Cj, which is the cost of your each decision variable, and here this is the solution values. This is the solution values, and here variables in basic. Is variables in basic. So which one is your basis variable? That is defined by b, and the solution is defined by your small b. That is the value of your values. Okay, and here this is cost of each solution values. Okay, and here your equation, that is your equation in the form of matrix form, that is ax equals to b. So their variables are x1, x2, x3, and s1, s2, and s3. Okay, and cost of each in the maximization problem. So in maximization problem there is 3x1, so cost of this is 3, 5x2, and 4x3, 0s1, 0s2, and 0s3. So this is your problem of objective function. So that's why you can write here. Okay, and here the matrix, that matrix is A. So A matrix is 2x1. First equation is 2x1, 3x2, 0x3. Okay, and s1, and these two are 0. Second equation is 0 of x1, 2x2, 5x3. Okay, and s2 here, so that's why we write s2, and this is 0. And third equation is 3x1, 2x2, and 4x3, and s3, so that's why these two components is 0 and here. Okay, so here we write the coefficient of each this x1, x2, x3, and s1, s2, s3 of three equations. Okay, and here your initial basic solution by setting x1, x2, x2 0. So these initial solutions are s1, s2, and s3, and these values are you get by equating x1, x2, x3. These values are 8, 5, and 15. Okay. So in previous page, you have already calculated what is the value of S1, S2, and S3. And cost of S1 is 0, S2 is 0, and S3 is 0. Okay. Because here already given S1 is 0, S2 is 0, S3 is 0. Okay. So you have to calculate value of this, what is your Z here. So Z is on putting this S1 is 8, S2 is 8, S3 is 15. Your objective function that is 3 of x1, and x1 is 0, x2 is 0, and this is 0. This means z equals to 0. You have to find out what is the value of zj, okay, and then what is the value of cj minus zj. Okay, zj means we have to multiply this cb, this column with this column. Okay, so this transpose with this. Okay, 0 into 2 plus 0 into 0 plus 0 into 3. This becomes 0 because this is your vector, that is your 0 vector. If you multiply here with this is again 0. Multiply this is again 0. This is CB into this column, this is 0. CB with this is 0. CB this is 0. We have to find out Cj minus Zj. This is your C1, C2, C3, C4, C5, C6. Okay. So here, this is Cj means C1, C2, C3. Okay. This first one is 3 minus 0. 3 minus 0 is 3. 5 minus 0 is 5. 4 minus 0 is 4. 0 minus 0 is 0. You have to find out these values Cj minus Zj. Okay. So if your problem is of maximization problem, if your problem is a maximization problem, you have to choose largest positive. Okay. And if your problem is minimization problem, So you have to choose largest negative. Okay, this Cj minus Zj values. Okay, Cj minus Zj. So here, which one is your largest positive? So this is your largest positive value. This is 5. Okay, so this means this value is corresponding to your x2 vector. So this means this is your key column. Okay, so this is your key column, and this x2 will enter into the basis, enter into the basis. Okay, and when this if this is when we say that this is your visible when this is greater than 0, and when this is optimal one when all cj minus zj is less or equals to 0. Okay, so optimal maximum के केस में optimum कब होगा? What is when we get optimum solution? In all cj minus zj is less or equals to 0. In that case we get optimum solution. But here all cj minus z0 is not less or equals to 0. So in that sense here this is not your optimal solution. So this means here we have to a chance for going to find what is the optimal solution. Okay, so here this x2 is your key column. So x2 is your key column. Okay, so this is your this enter into the basis. Okay, so now we have to find out this is your key column. So that's why we mark that specific column, that is column C2. Okay. So here we have to find out what is the minimum ratio. This is the test for optimality. Okay. So this is test for feasibility and this is test for optimality. So we have to find out the minimum ratio. What is your minimum ratio? Minimum ratio means we have to select it that XB means this XB over which one we our key column. Key column is this thing. Okay, so we have to this key column is x2. We have to find out the corresponding ratio. So this is 8 over 3 because xb value is 8 here and this is 3. We have 10 and 2, which is 10 by 2 here, 15 by 2 here, 15 by 2. And one thing is remember that here this all x2 which is greater than 0. Okay, suppose if any increase, suppose in this column here that is 0, so that is not to be consideration. Okay, so because if you divide it by 0 here, so that this is a indeterminate form, or you say to say that very large, and here we have to find the minimum ratio. That's why if any increase that is either 0 or negative 1, so in that sense we have to doesn't find that ratio. Okay, and we have to neglect that okay. Here 8 by 3, this is 10 by 2, this is 5 here, this is 7 by 2, this is 7.5. Okay, so this among these three we have to find out the minimum ratio. This is 5. Okay, and this is 7.5, and here this is approx 2 point something. Okay, so this will minimum is this 8 by 3. Okay, this means this is your minimum ratio. So this value is minimum. Okay, this is minimum. So this means this corresponding to which vector? This is your x1. Okay, so this means your s1 is your this is your basically the key row. This is your key row. Okay, and the intersection of this key, this is your key row. Okay, so intersection of this key row and key column, this element is your key element. Okay, this is your key element. Okay, which is intersection of this column and row. So this is your key element, and you make this is by using e operation. You make them this becomes one here, and by using e operation, you have to subtracting from that. This becomes 0, and this becomes 0, and using your e operations. Okay, and here this is corresponding to minimum ratio, that variable that is leave the basis. Okay, so here you should write here the variable s1. So here the variable s1 should leave the solution, should leave solution. Okay, so now here if for this key element is making to one, so if there is a suppose there are three rows r1 r2 and r3, so here we have to operate our r1 is r1 by 3. So if we operate r1 by 3, this becomes 1. Okay, and here this becomes 8 by 3, and this is 2 by 3, this is 1 by 3. Okay, and so on. And then we have to make this term, and this term is 0 here. So we use this r2 to r2 minus 2 2 times, because if we make this is 1, so 2 times of this r1 and that r1 new r1. Okay, so this one is new after dividing by 3. Okay, and what is your r3? So r3 is 2 of r1 new. Okay, so by using these e operation, so the vehicle is produces in this form. So second iteration, second table, this is Cj, this is B solution values. This is variable, this is variable, and suppose this is your cost vector. Okay, and here you this S1 will leave the solution and X2 will enter here. So here the first one is X2 because X2 enter and S1 leave, and remaining are same. This is S2 and S3. And what is the cost of S2 is 5. So here we write here this cost is 5, and S2 is 0, and this has 0. Okay, and values of this S2 is, if you dividing by 3 here, this becomes 8 by 3. So this is 8 by 3, and here the variables are x1, x2, x3, s1, s2, and s3, and the cost of corresponding decision variable are 3, 5, 4, 0, 0, 0. Okay, so now here we make this entry is 1 by using e operation. So this entry is 1. So here this is a 2 by 3, 2 by 3, and here this is 0, this is 1 by 3, this is 0, and this is 0. By using e operation, we make this increase as 0, and here this increase is 0 by using e operation. So for the same operation we're doing here, so this becomes a 14 by 3, and this is minus 4 by 3. Okay, and this term is 5. This is minus 2 by 3 by using e operation. You find out these values, and this is a 29 over 3. This value is 5 by 3. And this is 4 minus 2 by 3, 0, 1. Okay, so now you have to doing same procedure as ever. So here you can find out what is the value of here. So what is the value of z here? So z is your problem is your maximization problem that equals to 3x1, 3x1. So x1 is 0 here, but x2 values you get here, x2 is equal to 8 by 3 here. Okay, so 5 of x2. So 5 of x2 means 5 of x2, this equals to 5. x2 is 8 by 3. This becomes 40 by 3. Okay, so here z equals to 3 by 8. Okay, so now in first step your z is 0, and that you find some the better approximation. Okay, so better result because z equals to some approx that equals to 13 point something. Okay, so here this is 0, and here some values here. Okay. So now if we find out what is the value of Cj minus Zj, okay, so Zj is, if you multiply here, so this becomes 10 by 3, and here if you subtracting from that, okay, so here we can write what is the value of z here, and then what is the value of here. Okay, so we can write Zj. Zj is, if you multiplying here, that becomes 10 by 3, and here is 5, Here this is 0. If you multiplying here, this becomes 5 by 3. This corresponding this to this. Okay. So here 5 to 0, this becomes 0. And here this is again 0. Okay. So this we multiply by this CD because our formula is ZJ that equals to CB. And here we can write that is YJ. Okay. So this is a CB of YJ. YJ means this is your Y1 column, Y2 column, Y3 column, so on. Okay. So that's why we get these values. Then what is the value of Cj minus Zj? Cj is 3. 3 minus 10 by 3, that becomes minus 1 by 3. And here if we subtracting 5 minus 5, that equals to 0 for this case. Okay. And here 4 minus 0, this becomes 4. And here this is minus 5 by 3, and this is 0 and 0. Okay, so here we have to find out which one is the largest positive. Largest positive is this is largest positive. Okay, this is largest positive corresponding to your x3. So this means x3 will enter into the basis, Okay, so you have to find out which one largest. You have to find the minimum ratio. Okay, what is the minimum ratio? Minimum ratio or is you have to calculate the minimum ratio. So here this minimum ratio is 8 by 3. Okay, so here 8 by 3 and here this is 0 1. Okay, here 0, so that we have to not find here. Okay, and here is 14 by 3 divided by 5. So this equals to okay. And here this 29 over 3 divided by 4. Okay, so this becomes so which one is your lowest? So this is your minimum one. Okay, so that's why this is minimum. This is minimum. So here we get this is coming from S2 row. Okay, so that's why we take this variable S2 will leave the solution. So this is this will leave the solution, and this is enter into the basis. So S3 will enter here, and S2 will leave solution. And you have to make this increase. This is your key element, and you make them as equals to 1 here. Okay, and this is already 0. So plus say up to 0 करना होगा. Okay. So now our next table or next step is okay. So on next page,
सर हेलो.
हाँ हेलो
सर की पॉइंट के नीचे सर एलिमेंट को 0 बनाना कंपलसरी है?
ये जो की हाँ
यस
सर, की एलिमेंट है, इस एलिमेंट को आप बाय यूजिंग ई ऑपरेशन आपने किया, ई ऑपरेशन करके आपने इसे 1 बना लिया. बाय यूजिंग कैसे करोगे? ये R2 है ना, ये आपका R2 है. इसमें आपको क्या करना होगा? इसमें आपको करना होगा दिस इज यू हैव टू राइट डाउन हियर R2 को आप करना होगा 1/5 ऑफ R2. ओके, एंड दिस करने के बाद आपके पास ये जो R2 आएगा वो दैट R2 इज R2 न्यू. ओके, और यहाँ पे देखें तो यहाँ पर देखें तो ऑलरेडी 0 है. तो अब इसे 0 है तो यहाँ पे कुछ नहीं करना. हाँ, तो R3 को आपको क्या करना होगा? तो R3 को आपको लेना होगा दैट इक्वल्स टू R2 because this position is 1 here. So R2 this R3 और R3 को हम चेंज कर रहे हैं ना, this is R3. So R3 minus we have to change that R3 minus 4 times because here this is 1, 4 times R2 new. R2 new. तो ये ऑपरेशन आप करोगे तो दिस तो R3 आपका क्या होगा? इस पोजीशन में क्या होगा? आपका 0 हो जाएगा. यहाँ पे सपोज कुछ और नंबर होता तो इसको भी आपको 0 करना होगा. तो करस्पॉन्डिंग आपको जो भी की एलिमेंट होगा उसे 1 करना है और उसकी करस्पॉन्डिंग एंट्रीज को सभी को हमें क्या करनी है? 0 बनानी है बाय यूजिंग ये ऑपरेशन. और उस ऑपरेशन को करने में हमारी सारी एंट्रीज क्या होंगी? चेंज हो जाएंगी. चेंज होंगी. ठीक. तो नेक्स्ट पेज पे चलें और ये ऑपरेशन हम करते हैं। हाँ नमस्कार, इसमें से क्या हाल है? अच्छा, क्लास ले लेते हैं उसके बाद देखते हैं। हाँ, पेमेंट हो गया शायद, बिल का डिपार्टमेंट का भी देखते हैं। तो अभी डिपार्टमेंट क्लास के बाद देखता हूँ। तो नेक्स्ट टेबल, this is CJ and this is XP, this is basis variable and cost variable. So now your basis variable are change here. S2 will leave the solution and X3 will enter here. So we write S3 and S3 is remain there. And cost of X2 is here. Your variables are X1, X2, X3, S1, S2, and S3. And cost are 3, 5, 4. Here 0, 0, 0. So here X2 is 5 and S3 is 4. So 5, 4, and this is 0. So this is your next table, and here you increase that increase is in X3 table, and the second one you make this entry as 1 by using E operation. So if we making that entry is 1, so your X2 is 0, and this is by dividing by 5, so this becomes minus 14 by this, and this is 14 over 15, and corresponding those are minus 2 by 15 and 1 by 5, and here 0. Okay, and now we, by using E operation, we make this one 0 because this is already 0. So here it doesn't change here. So this becomes 1, and here 2 by 3, and here this value is already 8 by 3. Okay, but this row, third row, by using E operation, this entries are changed. So this becomes 0, is 41 over 15, and this is 89 over 15. Okay, and these entries are minus 2 by 15, minus 4 over 5, this is 1, and this is corresponding to this 0, this 0, and this is 1 by 3. Okay, so these are the entries. So okay, so now in this case you have to find the z. So the value is 3x1, so x1 is 0 here. 5 of x2, 5 of x2, and x2 equals to 8 by this. 5 of x2 means 8 by 3 plus 4 of x3 means 4 into 14 by 15. This value equals to 265 by 15. Okay, so now this is your value of z. So we have to find out what is the value of zj, and then what is the value of cj minus zj. Okay, so here if we multiplying this column with this column, okay, we have 5 into this, 4 into this, 0 into this. So here this equals to 34 over 15. Okay, and this value is 5, this value is 0, zj. So if we multiplying here, this is not 0 because 5, 0, 4 into, so this becomes 4 here. Okay, and this becomes 5 here, this becomes 4. This 4. Because this 4
सर
into
4
1.
होगी वैल्यू वहाँ पे,
कहाँ पे होगी 4?
नहीं जो आपने लिखी थी x3 के नीचे zj की वैल्यू,
ये ना, ये जो हमने लिख रहे हैं ना, ये हाँ हाँ नहीं, ठीक है, मैंने इसको करेक्ट कर लिया, 4 होगी क्योंकि ये मल्टीप्लाई कर रहा है ना ये, और फिर इस तरह से मल्टीप्लाई कर रहे हैं तो दिस बिकम 17 over 15, this value is 4 over 5, this value is 0. And if you're subtracting 3 minus this equals to 11 over 15, and this 5 minus 5 is 0, 4 minus 4 is 0, and here minus 17 over 15, and this is minus 4 by 5, and this is 0. Okay, so here for optimality, this 0, this is negative, this is negative, this is 0, this is 0. Suppose this is negative, then this solution is our optimal result. But here, all increase, all Cj minus Zj are not less or equals to 0. So here, because this one entry is positive one, okay, so this is only one entry which is greater than 0. So this is your largest positive. So that's why this enter into the basis, and that variable is your x1 variable. Okay, so this is your key column. So you have to find out the minimum ratio for this x2 8 by 3 upon this 2 by 3. We have to find the minimum ratio, and this one is negative one. Second, it is negative, so that's why we have to calculate that, because here the condition is all x bj is greater than 0. And here the last one is 89 over 15 divided by 41 by 50. Okay, so here in that sense you have to find this one is a minimum, because this is approx 2 point something, and here this is 4. Okay, so this one is minimum. That's why this value is minimum. This means this is S3 will leave the solution, and this is your key row. Okay. This an intersection of this is your key element. Okay, you have to make that is 1, and by using E operation you make this is 0 and this is 0. Okay, so here this S3 will leave the solution, will leave the basis. Okay, and here S1 will enter. Okay, so now your next solution is CJ, XD, D, CD, and here X2, X3, and this S3 will leave the solution and X1 will enter. So X1 will enter. Okay, so now by using E operation, so your table is 1 by dividing the R3 will dividing by 51 upon 41. Okay, so if this 15 are cancelled out, so this becomes 89 over 41. Okay, so this value is equals to, this is 89 by 41 with 15 by 41. You make E operation, you make this 0 and this 0. 62 over 41, and this is 50 over 50, this is 5. Okay, so now what is your Z? Z, if we calculate the value of Z here by using these values, your Z is 765 over 41. Okay, and what are the values of Cj minus Zj? And if all equals to 0, then there is your optimal solution, and you have to stop the procedure. So here you have, so here this is 3, 5, 4. Columns are by using E operation. This is 1, 0, 0, 0, and 0, and here 15 over 51 minus 10 over 51, And this implies are minus 6 over 41, which is 541, which is 441, and this one is minus 241 minus j. So here value, if you multiplying here, this becomes only 3, 4. Okay. And here multiplying and adding, subtracting, then this value is, you have to check that this is correct or not. Okay. ये आप कर लेंगे, सिंपल एल्गोरिदम है, इसमें कुछ ऐसा कॉन्सेप्ट नहीं है, सिर्फ अप्लाई करना है और सब्ट्रैक्ट करना है, ये सारी चीजें। आप दिस माइनस दिस करें तो दिस इक्वल्स टू 0, यहाँ पे आपका 0 हो जाएगा, ये 0 हो जाएगी, और यहाँ पे आप करेंगे तो दिस इज माइनस 45 ओवर दिस इज माइनस 24 ओवर 41, एंड दिस इज माइनस 11 ओवर 41. So these are negative, these are zeros. So all entries are here, all ck minus zk is less or equals to 0. So this means you get optimal solution. It is 62 over 41. What is x3 is 3. X3 is 62 over 41. And what is the maximum value of z? This is equal to 765 over 41. So this is optimum value, and this is the optimum value. Okay. You have to stop there. Errors are x1, x2, x3. तो यहाँ पे आप देखें x1, x2, x3 जो वैल्यूज हमारी ऑप्टिमल सोल्यूशन, बेस्ट सोल्यूशन होने के लिए हमारे वेरिएबल्स की वैल्यू ये आ रही है, बट यहाँ कोई रिस्ट्रिक्शंस नहीं लगे हुए हैं कि x1, x2, x3 हमारे जो है इंटीजर होने चाहिए, नहीं। हाँ, उस केस में यहाँ जरूर ये सेंस नहीं है कि 89 और 41 हमें वर्कर्स चाहिए। ओके, तो दिस मींस यू हैव टू आइदर टेक 2 वर्कर और 3 वर्कर। वो आप वहाँ पे हम डिफरेंट मेथड्स हैं, दैट इज गोमेला चेन मेथड है, और हमारे पास कई सेवरल हमारे पास मेथड्स हैं जिनको हम इससे सॉल्व करते हैं। तो इसलिए हम अभी जो आ भी नहीं रहे, और सिंप्लेक्स मेथड हम इसलिए डिस्कस कर रहे हैं क्योंकि सिंप्लेक्स मेथड हमारा बहुत ही ऐसा एल्गोरिदम है जो कि हमें बहुत सी प्रॉब्लम्स में, नॉन लीनियर प्रोग्राम में भी होते हैं, बहुत जगह यूज होते हैं हमारे सिंप्लेक्स, इसलिए आपको ये जाननी चाहिए। ठीक है, हमारे लीनियर प्रोग्रामिंग ऑप्टिमाइजेशन में बहुत से मेथड हैं, पर हम सबको हम नहीं कर सकते, ना हमारे पास समय है और ना आपका सिलेबस ऐसा अपने करता है। तो ऑप्टिमाइजेशन में तो बहुत सी टेक्निक्स हैं, बहुत सी चीज़ें हैं, लेकिन सबको हम लोग लिमिट टाइम में, लिमिट सिलेबस में, लिमिट एक सेमेस्टर को में, हाँ, बाकी तो आप फ्री हैं डिस्कस करने के लिए, सारी चीज़ें हैं। तो मेथड की मिनिमाइजेशन प्रॉब्लम भी करा देंगे, हाँ, आर्टिफिशियल वेरिएबल्स की, और उसके बाद उसमें हम कंप्लीट करा देंगे बिग एम मेथड, टू फेस मेथड भी अगर टाइम मिला तो भी करा देंगे। उसके बाद फिर उसकी कुछ सिंप्लेक्स में, हाँ हाँ बताएं।
सर ये जो आपने वैल्यू निकाली है 40, इसमें सर S1 कॉलम में 45/41, सर यहाँ पे 5/41 वैल्यू आ रही है।
कहाँ पे हो सकता है
सर ये जो ZJ की वैल्यू अपने S1 कॉलम के लिए निकाली हुई है 45/41, यस सर यही वाली, सर यहाँ पे 5/41 आ रहा है।
If you multiply 15 and 5, this becomes 75, and 4, 6, 24, and 3, 2, 6. Okay, तो दिस वन 30।
सही है, सही है, सही है,
हाँ ठीक तो
सही
है।
है सर, थोड़ा सा सर
हाँ हाँ, नहीं नहीं, हो सकता है, हो सकता है, वो बताया ना। अब ये सारी चीजें हैं, ये बड़ा ही कंसेप्ट में कुछ नहीं है, लेकिन आपको जो कैलकुलेशन करने होंगे वो बड़ा ही वो होगा, जैसे सब्ट्रैक्ट करना, फिर इसमें से करना, ठीक है। थोड़ा सा है तो प्लस माइनस का थोड़ा ध्यान रखेंगे आप, थोड़ी सी दिक्कतें होती हैं। ये सारी चीजें हैं, बट हम सिंटेक्स में सारी लीनियर प्रोग्रामिंग प्रॉब्लम्स को मैटलैब पे बड़ी इजीली हमारे पास कमांड है, उसके थ्रू आप कर सकते हो। तो हम आपको जो भी सिंप्लेक्स और ये सारे हैं, हम आपको मैटलैब की कोड्स हम एक व्हाट्सएप ग्रुप पे हम आपको फोटोज की भेज देंगे, ठीक है। तो आप कोशिश करना कि अपने लैब में उसको करने की कोशिश करना, अगर आपके पास मैटलैब लैब के थ्रू करने की कोशिश करना। तो हम आपके लीनियर प्रोग्रामिंग प्रॉब्लम में जो भी सिंटैक्स मेथड है या फिर ये सारी जो मेथड्स हैं, उनका मैटलैब कोड हम आपको भेजेंगे, शेयर कर देंगे, ठीक है। तो अपने जस्ट फॉर प्रैक्टिकल एग्जामिनेशन के लिए आप थोड़ा उनको आप प्रैक्टिस थोड़ा कीजिए, ठीक है। तो और आपकी एग्जामिनेशन जो है वो 25 जुलाई से स्टार्ट होंगे, और जिन्होंने अभी तक अपने असाइनमेंट नहीं भेजे हैं, असाइनमेंट बाय मेल व्हाट्सएप और मतलब भेज भी दिया है और उनको हमारी तरफ से रिसीव का कंफर्मेशन नहीं मिला है, तो वो सभी आज तक भेज दें। आप अपने ग्रुप में एक बार इसको शेयर कर लें कि आज तक हमें सभी मिल जाए। जिन्होंने नहीं भेजा है, जिनको कंफर्मेशन भी नहीं मिला है, वो व्हाट्सएप पे भेजते हैं हमारे, क्योंकि कल से पोर्टल पे मार्क्स कर जाएंगे, और जब मार्क्स हो जाएंगे सबके फाइनल, तो फिर प्रॉब्लम हो जाएगी, ठीक है। तो आप उसे कह रहे हैं कि ज़्यादा से ज़्यादा वो आज नहीं तो कल तक वो जरूर भेज दें, ठीक है। चलिए आज के लिए इतना ही, थैंक यू।